Good afternoon, everyone. Welcome. I think we're on the green channel, or if you're behind, then everything is audible without headphone. Recently, I acquired a road bike, secondhand, a race bike. And you might think, why do you need all these gears in a Dutch landscape? Well, if you want to race, gears are handy to have. It was secondhand, and I had to do some maintenance on it. So the chain was worn out. The cassette was worn out, and I had to investigate or dive into the topic of your own bike maintenance. And while investigating, I figured out that the free hub has some hidden components in there that make your ride really smooth and efficient. And one of those components is the ball bearing in the rear axle. And in some sense, I see the service mesh as being the ball bearing in our IT landscape. And that's what I want to talk to you about today. So my name is Jens Kat. I'm a product owner, a developer in the ING service mesh team. I have been doing this for 12 years, 8 years in the service mesh area. And ING itself currently has about 2,000 services running with our service mesh. To give you a sense of scale, well, ING is a financial institution. We work globally, worldwide, and we are present in over 40 countries, and we serve about 40 million customers. Well, most of you attending here are developers working on and solving hard and complex development problems. So thank you for being here, and let's dive in. Today, I want to talk to you about how we got here in the service mesh. What is it? Give a definition of the service mesh at ING and in general, and then look at how we implement this in ING and what we learned along the way when adopting a service mesh architecture. At the end, there will be some lessons learned that you can take away to your own situation or company. So we start about, let's say, 10, 50 years ago, when your application was serving traffic, was making customers happy, and you had such a success that you needed to scale up, scale out, and you started hiring more teams. You need to write code, adopt, increase the features in the app. And with this, well, the design decisions you made at the start, you had a large app calling the banking application. You slowly felt the increase of technical debt. Your deployments became slower. You overall had to roll back deployments. Customers were not satisfied because they had to wait for 3 months on a feature instead of the promised 1 week. And all in all, the customer satisfaction goes down. And also the developer satisfaction goes down. And something had to change. So you have your large banking application or application in your domain, and we had to do something about this. And this is where the microservices architecture comes in. You have your large application, your monolithic application, and you want to split that up into its own domains, where teams can work unconnected, or at least protected by, stay in their domain, have their own velocity, have their own deployment strategy, have their own schedules, a release cycle. And now the developer satisfaction goes up, your customer satisfaction goes up, but this splitting up of a monolith into a microservices architecture does not come for free. With the scaling out, or with the adoption of microservice architecture, you typically don't need these large VMs or a bare metal service anymore. You say, I want to be able to rapidly scale up. So these are another business requirement that you impose on yourself by having success. And you don't know your the VMs that you used to have in your SSH list, where you could hop on blind in the night to solve incidents. They don't exist anymore, and they all are ephemeral. And you have to be sure that the things you're now treating as cattle instead of pets, so you don't know the service where they run anymore. And everything keeps working, but at a cost. And the first one is, how do you, as a your consumer application, how do you find your current landscape where you need to navigate? How do you find the producers that you need to have a successful request? And typically, you don't need only one server that you send requests to, but you have a handful. And in the case of ING, if you have the mobile app and you start listing your accounts or your transactions, those typically go through a handful of services, 5 till 10, before all the data is there and composed together and presented to you in your web application or in your mobile application. So this is where the concept of service discovery comes in. Service discovery is something that we need when we run our workloads decoupled from location. So we don't know where they run, but we should be able to discover those. Next to that, we start adopting the mindset of everything is insecure, or at least we should have this zero trust mindset that we don't trust anything on the network. And this is where the TLS requirements, security requirements are imposed on all those connections that you now make between consumers and producers. With those security requirements, you can now validate that only the allowed set of users or the allowed set of applications can talk to each other. So there are no adversarial attacks possible. Another thing that you now impose on yourself by adopting a microservice architecture is that besides service authentication, using mutual TLS, for example, you also have the issue of authorization. So you start implementing an API, a set of endpoints that deliver features on their own, but you don't want to expose all those endpoints or all those capabilities to anyone that is authenticated. So you need to lock down specific capabilities, or you need to lock down access to those endpoints to make sure that everything is still in the right hands and secure. So in this example, you don't want to launch rockets when you only need to be able to list or to create a report. Over time, your landscape will look like this. You have decoupled everything. Everyone is on their own, and everyone has to follow the same rules. And those rules are imposed by the organization, imposed by the best practices that we learned over time. And this is what it can look like, and you have a chain of service calls before everything before the customer is satisfied with the request. So a lot of technical concerns come together. And this is what we talk about, or what we mean when we talk about service mesh. So it's all the services working together in a mesh, and that taking care of the technical integration is what we call the service mesh. It provides the interoperability to connect all the services wherever they run, if it's on-premises, on VMs, in Kubernetes in the cloud. It doesn't matter. The service mesh takes care of connecting those workloads together. With the service mesh, there is we say an application layer is being formed between the services themselves, and there are some properties attached to it, like security, observability, and resiliency, that emerge from having this distributed nature of the microservices. Now, you as a typical software developer, how will you encounter service mesh? It's an ephemeral thing, but typically what you see is you either have a library that integrates with the service mesh, and it takes care of the TLS handling or the peer authentication, or you interact with it through a sidecar proxy. And this proxy is then a process next to your application, the business application, taking care of the heavy lifting of the technical integration with other services. Now, what does it typically look like, and what does it look like in ING? When you talk about service mesh, you soon learn about planes. And with planes, you have, let's say, two flavors. And in ING, I think everyone has the third plane, but this is rarely talked about, where you have two planes. One is the control plane, and the control plane is kind of steering, managing all the workloads that are running in the data plane. And in the data plane, we have the business applications providing business value, customer value, requests, responses flow through the data plane. That's where the data lives. And the control plane steers the behavior of the apps, of the proxies in the data plane. One very important thing that comes, well, maybe not when your team, or when you have one or two teams working together providing APIs or microservices, but when you scale out, when you start running things at scale, you need to be able to understand what APIs or what endpoints are there, what can I connect to, and how should I consume them, what is the specification they have, and who is allowed to connect to what, and where is that registered, and not in a mail, but in a system. And we call that the developer portal, or API marketplace, where developers build and well, submit and subscribe to endpoints. Which is the first thing I want to talk about, how we do things in ING, and it's called the marketplace. So with running things at scale, and we are running in multiple countries, Spain, Belgium, Netherlands, Poland, Australia even, we have teams, businesses, building API specifications so they can be shared and reused with other teams, with other organizations. So we don't reinvent the accounts service in 20 countries. So there's a definition of what the account service look like, or the API look like, and it can be implemented by 20 countries for their specific local backends. The API marketplace, it fosters reuse because everything is open and you can investigate, is this already designed? Is someone already doing what I was supposed to do or had the idea to do? And it is also a very important part in the authorization model in our service mesh, where it's managing who is allowed to implement what API specification. And who is allowed, it gives the producers a means to subscribe to endpoints. So you can have this marketplace, the actual back and forth between I need this to fulfill my my business requirement, and now I am subscribing to you for 100 requests per second with maybe a peak of 500 requests per second, and you lock that down. You register that in the registry, so that anyone can see this disagreement between those teams or those applications. And this is what we then distribute in our service mesh. So if you look at how we enforce these subscriptions, we have here the overview of a consumer talking to a producer, and the producer had created a API specification. And in this API specification, it had two specific endpoints, generate a report or launch rockets. And the consumer needed to subscribe to the launch the rocket endpoint feature. And what it did in the marketplace, first of all, it found this capability is there and it's actually implemented by this service. And it could then subscribe to the endpoint, say, hey, owner of this endpoint, I'm interested in consuming this endpoint. Please allow me to do this. They had to back and forth, and then in the end, the subscription was there. And the subscription is then delivered to the consumer. And the subscription is a JWT, a JSON Web Token, that is being passed to the producer. And the producer can then verify, are you indeed allowed to consume and to talk to me? Did we have an agreement? And they do that by deriving from the JWT that it was issued by the governance plane, by the API registry. So that we have a full circle of, or chain of trust between the consumer, producer, and the governance plane. And we make sure that unauthorized access is impossible. Authentication is still done using MTLS. The cool thing about this is that the consumer, well, the change is consumer-driven, because the producer just has to approve something in a portal. From that moment on, the going live is in the hands of the consumer, because the producer can verify that the token is issued by this body or this thing that it trusts, and then everything is fine. If we then look at how do these services find each other, we have the thing in the control plane, which we call API endpoint discovery. Typically, you have here service discovery. I also had it in the intro slide. API endpoint discovery, what we do there is instead of discovering services, so the account service or the I don't know what, other service, we do this on API endpoint level. And this allows us, with our fine-grained subscription model in the marketplace, to only give access to endpoints, to features of a API, to hand them out to a select, or to really scope it down. So you can think of API endpoint discovery in the limit as being a service discovery where every service implements one endpoint, implements one API with one endpoint. But I think for the rest of the talk, service discovery is good enough. And it's the phone book of the service mesh. So where do you find where you should send your request to? You look it up in the phone book, and then you get back an answer, and then you can start sending requests, update that regularly. The API endpoint discovery, or the workloads in the service mesh, have this announce and query model. So they announce themselves when they start up. This makes sure that the host, the port, service name, all those things are known. And API endpoint discovery will verify that this workload that is now running is actually allowed to implement that API. So that is part of the API registry as well. So we have the governance plane that hands out those permissions. You are allowed to implement this endpoint, and you can go live with this endpoint. So this prevents us, or in general, that teams can, let's say, hijack endpoints or services from other teams. So only the API owner can hand out those permissions to services. Next to that, our control plane also provides runtime configuration. And in this runtime configuration, we'll have an example later on, but this is like the weights in service mesh. How should we route traffic? Should traffic be routed in the first place? Those kind of things are also issued and handled by API endpoint discovery. Now, let's step one plane down. So we had the governance plane, we had the control plane, and now we have the data plane. And in the data plane, or in a microservices architecture, you have the three pillars that you need to have, at least in ING, I think in the market as well. First of all, you need to have secure traffic. Everything is distributed, and you have this zero trust model. So we already handled the authentication and the authorization. Authentication by certificates, mutual TLS. Authorization by those tokens issued by the governance plane. And next to that, we have observability. So everything is running anywhere, and you don't want to be called at night, say, OK, I have no clue what's going on. You need to be able to pinpoint this very fast. And you have three things for that: metrics, logging, and tracing. I won't dive into the details of those, but when you have a distributed microservice architecture, those are things that you need to have in place before you can go live. Then, because everything is over the network, the third part is the resiliency of your workloads. So the network is unreliable, and you need to be able to handle with those downtimes or routes not being in place, firewalls being closed down, or timeouts anywhere. So you, on your workload, also have to think about doing, for example, client-side load balancing, doing timeouts or set timeouts on your request. Make sure you can retry them if it makes sense in your business case or in your use case. So those things, because we said we are slow, we have this monolith, we want to split it up. Every team is now responsible to bring things to production themselves. And by the way, you also have to fulfill this list of 30 things to comply with running a microservice. That's a lot of things to take care of as a single team, and especially in the numbers, when you think about, we have about 2,000 apps running in production. When I have to tell 2,000 apps or 2,000 teams, more or less. Oh, by the way, we have a new requirement. Please update all your apps to also send field X in a tracing event. Then you can imagine the churn or the waste we have to keep everyone on the same page. And this is where in ING we have two products available. One is a library to take care of this specific same set of requirements, same set of things all the teams need to adhere to, or apps need to adhere to, or a sidecar. And the sidecar process is something that takes care of the technical integration. So we support both. Library is useful if you have, a homogeneous landscape where everything is JVM. You can support the JVM library. If you have a more heterogeneous landscape with Python, Go, you name it, then typically a sidecar pattern is recommended because you as an owning team have only to support the sidecar, and the rest is over HTTP handling the integration. Well, the success of using those things stand or fall, of course, with usage. So as with your business, only the value is brought when actual consumers use it. The same is, of course, for internal teams, and like my team is a platform team for those components. And to increase success, we have documentation in place. So it's maybe a giveaway, but if people don't know, first of all, that you exist, oh, there's a library, never heard of, you need to be able to share knowledge. And with one team, you can have one-on-one sessions, but if you have many teams, documentation does scale. Next to that, also have a community, start building a community. It grows slowly, but we do have bi-weekly meetups, as we call them, where teams can showcase what they built with our stuff, exchange thoughts on ideas, and that we can send to the community of the teams that are using our things to give a heads up on a migration guide or new features that we are developing. So there's this bi-directional communication channel with the community, and the community themselves also help each other say, oh, we implemented it like this, so that the burden, the support burden gets less. Another thing to consider is get insights in how your things are being used. So me as a platform team supporting the library, I want to know if feature X is adopted in the company by how many teams, or how do teams configure this and that. And this helps us be critical about the public interface that we expose, but also in evolving features that we develop. So we can sunset features because only 2 teams use them, so we can have a conversation with them. Or we can say it's a success because now 1,800 teams are on that version where this was the default. So having this pulse with your production workloads is really helpful in scaling out and being in control. Another thing that we experienced, and I think in the previous slide or the slide before that, you have to think about a lot of things. So one of them is certificates. So all of a sudden we said, wait, we don't trust anything on the network. You have to provide yourself or your app with a certificate. Well, certificates in the past, before the ACME protocol in 2017, it all was a manual process, at least with us. So you put a lot of, one requirement puts a lot of burden on all the workloads in production. So you have to refresh your certificates every half a year or whatever. You can automate this. At least nowadays, you can automate a lot of that, and teams don't have to care about those kind of things. The same with the subscriptions that are coming from the governance plane. You don't want to download that. You don't want to check that in Git. Say, OK, during my build, my workload is being built or configuration is being created, just inject that and don't care about that anymore. So we unburden teams by automation. Also for disaster recovery, for example, and we have API endpoint discovery as our control plane. We have disaster recovery in place between regions. We can automate that because we own the control plane. We can steer the traffic the way we want. after a couple of years, well, you start looking around, or maybe you already looked around, you say, wait a minute, there are cool projects starting, and we need to be able to adopt that, or to stay relevant and not lag. We need to be able to capture those advancements, like canary releasing, using Flagger or Kubernetes, doing cool stuff. So we are, as a platform team, conscious about the environment that we operate in. And we have come up with a, well, maybe well-accepted adoption or a set of how to handle this. Instead of, I get all kinds of notifications about my timing, check, almost there. So instead of, it's kind of like creating a BDD, behavior-driven development, or a test suite, a regression test suite that we introduced for our product, for the sidecar, for the library, where we capture this app or this workload should be able to handle, in this case, TLS version 1.2 with a set of ciphers. It should reject TLS 1.3 if it has this cipher. It should forward incoming tokens, validate tokens, forward tracing headers to not break the chain. So with having this, well, regression test set, we can validate new implementations like Envoy proxy that we're now rolling out, or validate that the framework and the sidecar process behave the same and don't cause interruptions in service mesh. By having this test suite, we can, well, implement and roll forward, evolve with confidence, and that's especially what test suites give you. The service mesh is an abstraction. So it abstracts away all those things that I just talked about. It abstracts away how to talk to other workloads. You don't know where they live, how to do authentication, authorization. That's all taken care of by the service mesh. Kind of as the same as a network interface card or NIC. You don't need to know about the retry mechanisms or the batching, stuff like that. You can know how it works. And you can talk to me, dive into the code, see how it works. But for teams, we just inject the sidecars at runtime, roll them out to VMs, and we take care of the details and the support of this solution. For us, we embarked on this journey 8 years ago. It has paid off. We have now 2,000 services running in production. So this was, for us, a good choice. And I think for you, if you want to either have it or adopt it, there are some lessons to be taken away. So a service mesh is a great abstraction, especially in a microservices architecture, but it isn't a free abstraction. Both the library and the sidecar have different target audiences. So I talked about the homogeneity of workloads, all in the same language. Then you could try supporting or adopting a library. We relieve teams by automating processes where it makes sense. And by capturing the behavior of the mesh, you can evolve it with confidence. Which brings me back to the ball bearing from the start. When things started squeaking, we started looking for a solution. And in our case, this was the service mesh. Thank you.